Hello and welcome to Ethereum Core Dev Meeting 62. Let's jump right into it. We're going to go to the summary if you click on action item 1, and we're going to review the actions required and decisions made and suggestions. All right, so we got action 61.1 is that Ganache slash spec compliance issue at Go Ethereum, that issue. We're going to come back to that in a couple of meetings. I don't. Do we have anything updated on that, or should we come to that in the next meeting?
David from Ganache here. Probably in the next meeting.
Okay, no problem. Review time frame for hard forks in June to refresh memories. Um, yeah, we'll do that in the next item when I pull up the link for the frames for June. Dano's going to add 9 month out hard fork kickoff time frames. That one. I'm looking here. I think that's done. Dano, did that one get done?
Yeah. I also am proposing for the next batch to add another checkpoint, which comes 2 months after the kickoff. EIP proposals would be due, which is kind of what we're doing, what we did last week and this week, and replacing what the checkpoint for EIPs due would be EIPs ready to give us more time to review and work through the EIPs before we hand it off to client development. So that's something I'm proposing for the next one. We'll see how this goes if we need it.
Okay, sounds good. Um, the next item is EIP 615 decision discussion at meeting. Status as a PR will be made. EIP 615 is the EIP for subroutines and static jumps for the EVM. And I guess that would be Brooke or Christian or Powell. And it looks like that was done, but I'm not positive. Is anyone here who can speak to that? Okay. Next, we have Martin and Alex to confirm whether EIP 689 needs to be implemented. It's a work in progress, and that was the status last time. This is the address collision of contract address causes exceptional halt that Yoichi originally drafted. Martin or Alex, is that have any update?
So no update,
Oh,
I guess, but as I've said before, it's not needed because 684 is already agreed upon.
okay. So we can erase that action item for
Well,
sure.
I have an update on that from the testing side that it still needs to be written in tests, and it's perhaps that the intention of the EIP was for it to be updated in yellow paper, which that hasn't happened. So like implicitly it exists in the clients because it's already been accepted, but explicitly it isn't in the yellow paper or in the tests yet.
Okay, and that can happen after it's explicit, after it is accepted.
Require a hard
I,
fork or
In my
anything like
think
opinion.
that.
actually it's in the tests as well, since because I think there are collisions in the tests for Create 2. It's not in the yellow paper, and I think that's because basically Yuichi was the yellow paper guy, and I don't think anyone picked up that after he left.
Yeah, I don't think we have any yellow paper person right now. All right. Another one is parity to comment on libraries for precompiles.
Yeah, the issue was raised if Parity has any objection to using like shared libraries for the precompiles, and it discussed that with the team, and no, we have no objection to that. But one comment might be is that yeah, using shared libraries kind of reduces the benefits of having multiple implementations, but we'll just leave it at that. But yeah, we can go forward with this and use the shared library there.
Okay. Action 58.1 was the cat herders looking at EIP1. Do the cat herders have any updates on that?
So the PR has been approved by I think 2 or 3 EIP reviewers, but hasn't been merged. So I don't know how it goes from approved to merged. But if it gets merged, then that action item is basically done.
Okay, Sounds good. And that means that you made changes to EIP1 or fixes, and you're waiting for those to be merged,
Yes.
but it's already been approved after a last call period or after some kind of discussion on there.
Yeah, and it's been approved for 2 or 3 weeks now. So happy. I'll link the PR again in the chat here, but yeah, no one has like voiced any objections so far.
Okay. And what we might want to do is make that a little bit more widespread using Reddit or Twitter or other means to make sure that people get their comments in, so it doesn't just stay under the radar and then people find out later what happened.
Yeah. There was an ETH Magicians thread, as well as I put a thread on ETHub's forum.
Okay. That sounds good. So that's all the actions required. The decisions made is that there's value in hard fork deadlines. That's 61.1. 61.2 is that the first deadline should serve as an upper bound for the maximum number of changes that might go in and subsequent hard fork and do a subsequent hard fork into Istanbul. But of course, not everything that is proposed by the deadline will necessarily make it into the hard fork. 61.3 is furthermore that as to this particular deadline 7 days from today, these EIPs today may still be in draft form. They're not expected to necessarily be thorough or complete, nor in accepted state, and of course not expected to have implementations ready. Okay, so I actually wasn't here last week. Can anyone elaborate on exactly what the summary of that decision was? It kind of makes sense, but in my opinion, that makes it a little bit unclear if it's in draft form, whether or not that's actually something that we can that needs to have everything complete before it's an accepted state.
Hudson, my understanding was that it doesn't need to be an accepted state by the deadline, just that there has to be a draft. But if anyone disagrees, speak up.
I agree.
Yeah, that's kind of what I read that as too. I was just making sure I read it right. EIP-615 PR will be made for this. That's decision 61.4. Let's see. I'm going to open that one. Subroutines and stat. Oh, that's already been addressed. So we don't have anyone to speak for that one, so we'll skip it. Suggestion 61.1. More than one EIP document are needed to address 3 things: a quality specification, a high-level proposal, and an intention to get your change into the next hard fork. Today we're kind of focusing on which EIPs are going into Istanbul, so we probably won't act on that suggestion today, in my opinion, unless someone feels strongly that we should. And then Ganache spec compliance issue at Go Ethereum. It would be helpful to spin it out into separate repos. Is suggestion 61.2. Does Ganache or Go Ethereum have any comments on that?
Nothing from Ganache.
Okay. Let's see. What is the next item? Okay, so part of the actions were to review the timeline for hard forks to refresh our memories. I think that happened last week, if the notes are correct, but let's go ahead and just go to the roadmap in item 2 and see what that says. So June 19th was the soft deadline for May 17th was the hard deadline to accept proposals for Istanbul. That was on an off week, so we're going to do that today. And then Friday on the 19th of August is the soft deadline for major client July is the soft deadline for major client implementations. And yeah, we'll go from there after that. Okay, let me see here. Oh, we have the hard fork happening after DevCon. Okay. Well, this will be a trick because we've never done that before. We usually try to have it before DevCon. That'll be interesting. Okay. So 3 is the
when I came up with
go
the
ahead.
proposed, well, actually, this is Afri's list for the proposed hard fork date. But when I did the windows, we didn't know when a DevCon was going to be. So
Yeah, we expected it to be in November at the time, I'm sure. Maybe we should change it to make sure it's not during DevCon, but then that would kind of wreck the rest of the timelines and stuff. Does anyone feel uncomfortable with having it so close to DevCon where people usually have stuff going on right afterwards or right before?
I wouldn't be comfortable making it any earlier.
You said you wouldn't or you would?
I would
I didn't
not
hear.
think making it earlier would be a good idea.
Okay, sounds good. Also, I guess on the bright side, if DevCon goes until the 11th and people stay over in Japan a few days, we would actually be in town for the hard fork or the test network upgrade. And then, or not for the test network upgrade, we would actually potentially, some of us, be in town for the mainnet upgrade if some of us stay in Japan a little bit longer. So that might be beneficial. Okay. And then the rough plan is for April 2020 for the next hard fork. If you want to go to the roadmap link, that'll give more information on that. And that's the rough plan that we'll decide here probably in the next month as a final plan. But it seems like everyone has agreed to that so far. Okay. Proposal for formal process. Okay, 4 is EIPs. Um, I'm on the wrong agenda. Luckily, the first 3 items are the same in almost every agenda. That was almost bad. Okay, so we need to refer to the roadmap list that's from the roadmap link. So we have a bunch of proposed ones. We're going to finalize these today as accepted or not accepted for the Istanbul hard fork. So subroutines and static jumps for the EVM. It looks like that one is done. The issue is we don't have anyone on the call that I know of who can speak to this one. Um, so I don't know if this actually wants to be put in or not. Can anyone speak to this one again? This is the static or subroutines and static jumps for the EVM.
They want it to be in, otherwise they wouldn't have put it there.
I mean, does anyone object to it? I guess is the better question.
Yes.
Or I mean, who has objected to it? Is the
Sorry, yeah, I object to it. And yeah, I guess it would be better if they were on, so we could have some kind of discussion about it. I don't know quite how to, should I lay out the reasons why I objected now, or do we want to have that?
Yeah, we can have them on the record. Just yeah, let's put out some reasons and then we can speak to them. I mean, it's not like we can't like between now and next Friday talk on Gitter and reach out to them and see if it's like something they can address.
Yeah. So I've written down my reasons why I'm not a proponent of it, and I'm not against it per se. I think it's I mean, it's a good thing in the end what they want to do, but I think that the benefits that we gain are not um, imperative with the overhead and the complexity of the EIP in total, because it brings a lot of complexity to the consensus engine. It brings a lot of overhead, as far as I understand it, to the actual runtime execution until we get to a point where the code is actually validated before it's deployed, so it can be executed without any additional checks. But if I understand it correctly, in the first iteration, it will actually make things slower because we need to do that verification at runtime. And the only way to get around that check is to also have the additional EIP with the EVM versioning, which means we have to do two pretty large consensus changes. One with EVM versioning at deploy time, and the second to implement this whole EIP. And the way I see it, the big benefits are basically better compilers and better optimizations during compilation, and also better verification. And that's especially adversarial verification, where you might not actually have the source code. Because if you actually have the source code, then you can do pretty good verification on an AST level of the source code. Yeah. So the way I see it, very complex, very large, and no real hands-on gains in the areas where I feel is most important.
Okay. That's a fair argument for not having it in Istanbul. I've also seen the argument that it should be divided into multiple EIPs if it were to be implemented at all. So that's something that should also be addressed.
Yeah, I would kind of echo that. I mean, if we want the versioning, if we want an deploy time verification and versioning, then I think it would be better to have that first and see that it works, and iron out any kinks with that, and then in a second hard fork have something that uses this versioning thing. I think it's a bit big to have the two things in the same hard fork.
Okay. Wait, am I unmuted? Yep, I'm unmuted. Um, okay. So this is an interesting process question for officially confirming EIPs to go into a next hard fork. Should the champion or at least one of the EIP authors be on the call in order for that to get approved? I don't really have a strong opinion either way on that. Does anyone have a strong opinion they'd like to suggest reasoning for?
I don't think the author needs to be on the call for it to be approved, but it would be a courtesy to not actually decline to not decline it unless they are there to defend their case.
Yeah, I mean, I don't think we should change the rule in the moment, but it makes sense for me from a process perspective that you show up to the call just so we can have these final discussions. Yeah.
Okay. So what we'll do is we'll try to reach out to the authors after this call and then make a decision using the All Core Devs Gitter channel and the Ethereum Magicians link that's already been posted with the EIP. And then Alex Bergzazi pointed out that the wiki is out of sync with the official EIP meta that has the links to what is being proposed. So, can I get a link to 1679? Alex, did you have that open?
I was curious also. Could we do like a quick run through the room if to get a lay of the land if people generally approve of 615 or if they generally are opposed to it? I mean, I've talked about this. I'd
Yeah.
like to hear the rest of people.
I have some thoughts to add on the EIP if one doesn't mind.
Yeah, sure, go ahead.
So I think one of the I can't really speak to the complexity of implementing the EIP because it is quite ambitious in scope. One of the I think the problems it attempts to address is at the moment it's quite extraordinarily difficult to write efficient smart contracts and efficient EVM code, and having some kind of abstractions regarding subroutine calls and particularly local variables would go in an enormous way towards bridging the gap between what you can do on the EVM and what you actually practically end up doing. Like when I've been writing optimized EVM algorithms, like generally as a rule of thumb, like writing it as EVM code, if you've got the constant time, is about 30 times more efficient than writing in Solidity. And I think part of that is because of the complexity of having of this of the stack abstraction and having things like the a local variable stored help immensely with this. Potentially even open up avenues to have compile real languages compile, not real, but established languages compiled to EVM code which would be quite useful. So I do think like there is a lot of substance behind this EIP, and it is an attempt to solve problems which do exist. It would be quite a boon if this was in the standard. I think from the perspective of a developer.
Okay, do we have any other comments?
I have some. So if in general we would like to improve EVM over time, I think that's the right direction to go. But I kind of agree about splitting that, and there are proposals how to do it on the practical level. And I mean, we can guess that at least two quite small features in this 615 EIP that can be implemented upfront. And yeah, I kind of agree with Martin about versioning. That think deploying that before we can actually verify a deploy time. I'm not sure about that. However, also I have some concerns about having versioning implemented and then never use it in the future if either this one will be delayed for a long time or for other reasons.
There are other EIPs with proposed opcode, so versioning if it's put in this one without 615 would still have meaning.
Okay.
Can you elaborate on that?
So for like the chain code ID, you could do a versioning, you could do the, 1706? I'm not sure what the number is, but the versioning to require that the versioning bits be there for the new opcode to work. And so we don't need 615 in for that versioning EIP to have meaning. So we could put those two together and still get a meaningful deployment of the versioning signaling inside of the EVM bytecodes.
We could also remove call code if versioning would be enabled.
Yeah, I agree that versioning is a pretty powerful construct, and I think it could stand actually on its own, even if 615 in the end is never implemented. Two things, or one more thing about versioning though, is that there are two types of versioning. One versioning is a type of versioning where a contract says, I want to play by these new cool rules and use these new cool opcodes. Another kind of versioning, which is for EWASM and 615, is that a version stamp made by the EVM saying, yes, this contract has undergone our scrutiny and is certified not to do illegal jumps. And whatever versioning mechanism we have, it should encompass both like opt-in voluntary versioning and also this seal of approval type of versioning. Yeah,
okay, anybody else? What I'm kind of hearing is that it's pretty much the EIP as it stands now, without it being split up, is something that would not be able to effectively go into Istanbul, according to everyone who's spoken up about the timeline portion of it. So that seems to be kind of a result. And although there's some good things in the EIP, it should be split up to make it a little easier to digest over time. So with that, I would say that we should definitely talk with their team and see what they think of that idea, and then pushing it back to April if that is something that we can like split it out in a way that makes it easier for people to agree on.
I have one question, quick question.
Mm-hmm.
So the EIP also mentions that one of the benefits beside the verifiability is performance. But can we actually put some numbers on that? So I haven't been following this EIP, so apologies if I missed this. But do we know exactly what performance improvements could be expected from this? So, for example, if I think the EIP mentions the C++ implementation. Do we have some numbers from how a smart contract could be rewritten and to perform better with this EIP rather than without?
I don't believe you have any numbers of that. Maybe they were done some time ago, but I don't have access to them. But what I know, there were not strictly benchmarking of that.
So
we don't have actively maintained implementation of it. However, it would be possible to do a site implementation.
So the reason I'm asking is because so I kind of have the feeling that people are a bit weary of this EIP because it seems large, but probably if we could put some numbers on it and demonstrate that it is good because this and this and this, then maybe people would be a lot more open to actually doing it if they can see some tangible benefits.
Yeah, as far as I've been able to tell in discussions, it has not been, I mean, the speed improvements, raw speed improvements has not been like the primary argument for this E. Not what I've heard.
One of the improvements is it's easier to map stuff to WASM if they put these in.
Yeah.
Okay, I can accept that reasoning, but then let's get rid of the performance arguments from the EIP.
Okay, that's something we can also talk to their team about. I'm guessing they probably ran something. But just to time box this, let's go ahead and move on to the next one. We got a big list to go through. And we'll follow up with this on the All Core Dev Getter channel. I'm going to write that down as a note for me to do specifically. Static jumps. Okay. On All Core Dev Getter. So the next one is 663 unlimited swap and dupe instructions. I think this one was already accepted. Yeah, this one was a simple one that was already... Alex, wasn't this already accepted? Am I wrong?
I don't think it ever was properly discussed.
Oh, okay.
But this,
oh, unlimited swap and dupe instructions.
But this would be something which can be made compatible with one of the proposals from 615. So this could be one of the ways to split up 615.
Okay. And it looks like it has all the necessary stuff within the EIP. Does anyone have any comments on it? Seems like a good idea to me, even though I don't really understand it. Okay, we don't really have strong feelings on it because maybe not a lot of people have looked into it. So we can just say it's going in. Oh, and if you hear background noise, that's my cats, so that's not me making chirps. Any other comments on this?
Yeah.
Okay, is this something... Oh, go ahead.
Yeah. Could someone again... So what would this enable? What are the big wins about this? Does it make the compilers
Alex?
work easier, or?
I was just trying to unmute. On one side, it is solving a similar problem to what 615 is solving with the subroutines. Because in the subroutines in 615, the idea would be that you could access multiple stack items. And they achieved that by introducing the get local, well, basically a local, they call it get local, but I think that's actually for the function parameters, the subroutine parameters. So in 615, you would have two ways to access items from the stack. And that means you would be able to access more than 16 items on the stack without moving items back and forth to memory. And 663 just extends the stack access to be able to access more than 16 items. Now, I think this has to be well discussed. I don't think in its current form without discussion this should be accepted, but it should be properly discussed, and maybe some limitations need to be put in. And especially consideration should be made so that this could be a precursor to the changes in 615. And the main benefit with accessing more stack items is making it simpler for compilers, for example, Solidity, to support bigger functions where people currently can experience issues like messages from the compiler to stack too deep, where they use too many variables or variables and input arguments. And the only solution developers have currently is to split those up into multiple functions.
So these swap n and dump n, are they 2-byte instructions which have like the push X, like push 1?
There are 3 options listed in the EIP. One is what you explained, having an immediate value. Another one is requiring a push upfront. Okay, technically it's not requiring a push, but rather taking the value from the stack. But you would want to extend this with validation that it requires a push upfront. But then we're getting into 615 territory. So I think this should be discussed in depth of this call, because this might take long.
Okay, we can definitely do that.
Question: pricing-wise, how does this arbitrary duplication compare to memory accesses? So why is doing dupe 255 better than pushing that into a memory slot and reading it later?
Well, it's cheaper because you don't pay for the number of slots used in the stack, but you do pay for memory extension.
It's also stack-based, which is good for recursive calls.
Mm-hmm. Yeah, okay, so I'm probably not going to argue against this because I'm not that familiar with the designs of Solidity. Just one thing I figured I would add is that since we do have 1,000, I think our stack limit is currently 1K. Honestly, I never really understood the reason of limiting accessing these items to only the top 16 words, because we're storing the whole thing in memory anyway. We don't have any specialized CPUs for Ethereum that would benefit of having the 16 limit. So from my perspective, removing this limit seems like a good extension, even if it's not too valuable. It just seems like an arbitrarily chosen limit that doesn't really make sense.
So it makes sense from the perspective that there's a limited number of codes and only the push instructions have data sections. And if we do option A, then it screws a bit with the jump test analysis.
Yeah, I think option A should only be introduced with together with account versioning or EVM versioning.
Okay, let's do any other comments in the All Core Devs Gitter chat, so we can move on to the next one, but it won't be going into Istanbul. As Alex mentioned, it'd be better to have a more full discussion on this. Okay, the next one is
Hudson,
1057. Oh, go ahead.
I do think pretty much every single EIP proposed needs more discussions. I'm
Okay.
not sure we can actually make decisions, maybe with a few exceptions on this list of 35, where we can say it's accepted or rejected. But I think the majority of them need a lot more discussions where we need to figure out whether they can be considered for Istanbul or not.
Well, yeah, but I guess what we can decide is which EIPs would surely not make it, and then everything that remains is tentatively slated for Istanbul, pending later consideration.
That's not ideal, but I guess that's what we have right now. So, yeah, I agree with you. I don't know if there has been enough coordinated discussion on all of these to make hard and fast decisions, except for the ones that have been discussed like a significant amount. And I think part of that is that there needs to be more Gitter discussion on certain ones and Ethereum Magician's discussion to kind of get at least a few people to say yes or no on some of these. So yeah, let's just run through these then and get a firm yes or no on the ones that we can, and then when we can't, we'll just have them slated as pending. So we would need another section on the meta, which would be actually no, we already have proposed. So we would basically have accepted and rejected on the meta, and then proposed would be the ones we can't decide today. So far 615 is can't decide today. 663 is can't decide today. 1057, which is ProgPoW. I already mentioned this in the on Twitter and on Getter and on Ethereum Magicians, but we had our hardware auditor not be able to do the audit anymore, and so because of that, and because of the fact that many of the questions that were brought up about ProgPoW had to do with the amount of time it would take to actually build an ASIC and the amount of time it would take, or the efficiency gains compared to a GPU, a group of GPU miners and stuff like that. We're going to try to put the hardware piece back in. I think we're approving a hardware auditor in the next couple days. We found one who doesn't have a conflict of interest, who isn't a giant ASIC manufacturer or anything like that. So that's really promising. But also, the reality of this is it won't get into Istanbul most likely because the audit will likely not be done before Istanbul. If that changes between now and the next all core dev meeting, I'll let everyone know since we still have some proposed ones to come up with. So for as far as the status, I propose that this go into the stay in the proposed EIP section as something that is still pending further information from the audit. Okay, doesn't sound like there's any other comments on that.
Yeah, I think it should not be dependent on the audit because that was not what was said from the beginning when we tentatively accepted it the first time and the second time.
I thought that the second time was that it was dependent on the audit.
But so wait, I'm guessing if the question is whether we would like to move forward with ProgPoW, that's kind of one thing or the other. That's not one decision. And well, if the audit finds something, then the clock can always be pulled up until the very last moment. And the question is that if the audit doesn't find anything, do we want to go forward with it? Because if yes, then people need to actually start implementing it. And if the audit finds some issues, then it's down the drain anyway.
Well, the problem is the audit might not get done until after the hard fork is our issue.
Right, but that's the hardware efficiency audit, right?
No, this is both software and hardware. I'm only speaking to the fact that the hardware one was delayed, which also delayed the software one, because the audit package was a package to be signed by all parties involved, and it wasn't able to be signed because of the dropping out of the hardware auditor.
Yeah.
So this is both software and hardware audit.
Yeah, okay, but I guess that doesn't really change whether the community wants or doesn't want to go forward with it.
Yeah, can I just quickly suggest we had these previous EIPs where we said if the person who proposed the EIP wasn't available, we would ask them to be available to have the discussion. Doesn't that apply to this EIP as well?
I'm filling that role as champion, even though I didn't author the EIP. I'm just listening to the discussion mostly. I do have one concern that I asked Hudson to add to the audit. I'll detail it into a getter, but I would want the auditor's opinion if we do it as written before we go forward, because I'm kind of the opinion there's one thing that needs to be changed. So I'll detail it in FEM as not to derail this meeting, but I don't think the EIP as written today should go forward without the audit confirming or recommending a change. So I'll detail that in a FEM thread.
Okay, so it sounds like if the de facto champion is saying that it shouldn't go forward without potentially a change, then that needs to be dealt with. So, yeah, I'm still holding my position that the likelihood of it getting delayed until April is greater now, because of the fact that the audit might not get done until after the hard fork, in which case we can't really take out something we've already put in when it comes to something like this.
Well, I mean, we can always do a double fork.
I love your jokes. But no, I think that the likelihood of it going to April is greater now, and that I will explore how long the audit's going to take over the next week, and then update the all core devs chat about it. So it'll just stay in proposed for now. Even though it has been tentatively approved pending the audit, according to the second time we approved this EIP, there's a possibility for a delay. CoinDesk, if you're listening, I have not officially delayed this at all. Neither has the core devs. We're just saying we need to spend more time looking at the timeline.
And I'll make sure that I'll get that EIP on FEM posted well after press time today.
Great. Okay. EIP 1108 is to reduce the alt BN128 precompile gas costs. Let's see if the champion is here.
Hi. Yeah, I'm one of the authors of the EIP, and yes, yes, hello.
Wonderful. And it looks like everything on here is this is the one for cross what's it called? For making multiple libraries for generic opcodes, is that right?
So that's not actually what this EIP is. That's EIP 1829, which is an EIP for a precompile that supports linear combinations.
Yep, you're right.
Generic elliptic curves. I can give a bit of a background to this EIP and why I think it would be a very strong value add to Ethereum, if that would be helpful.
Sure.
So this EIP has been in the works for a while, and in previous hard forks it wasn't included because, partly because the existing client implementations, like the runtime of the BN128 precompile algorithms, didn't justify reduced gas costs. And also the value of reducing the gas schedule was more speculative. However, things in the last 6 months have been changing quite significantly. There's a number of companies or organizations developing privacy-preserving technology scaling solutions on Ethereum. I'm CTO of Aztec, a privacy provider, so we're one of them. And we use elliptic curve cryptography extensively in our protocol, in our smart contracts, alongside the Rollup team, Metal Labs, Zeta. And at the moment, the precompiled gas schedule is quite a strong bottleneck to deploying more advanced and innovative crypto systems that could solve a lot of Ethereum's address some of Ethereum's technical limitations, such as a lack of privacy or a lack of transaction throughput. And so actually in the EIP, I can't give a description of those. Some of the things that, for example, we as would be deploying to Ethereum were the precompile costs low enough for this stuff to be actually practical, like things like confidential weighted voting, having like confidential decentralized exchanges with partial order filling over encrypted orders, things like that. And the rationale.
I'm gonna have to time box this to just another minute so we can go through the
Okay,
rest.
of course, right. So basically, both the parity and gas clients, the runtime of the algorithms is now fast enough to justify a significantly reduced gas schedule. It would help on quite a few people and institutions building on Ethereum today to do more advanced innovative things with Ethereum. And I think the whole ecosystem community would benefit from this EIP significantly. Also, for the the actual algorithms, they're already implemented in major clients, so the implementation work should be extremely light.
Okay.
I have a question about the benchmarks that you published. So the benchmark listed for the 2.11 beta release and the benchmarks after pairing optimizations, you're listing the exact same test vectors, and I'm just curious if you on the second time, did you take the exact same ones, or did you take the ones that were performed the worst?
No, we just so I just took I literally just took a clone of the previous benchmarks, ran the same tests, and compared them. There was no intention to kind of game this benchmark.
Yeah, I get it. But it would be interesting if you could run the benchmarks for the full set, because it's not sometimes the worst cases differ, especially when you change the implementation around and do optimizations, and suddenly one other of these test vectors become the dominant worst behavior. So
yeah,
it might be good to check all of them.
I'd be happy to do that and update them. I mean, I could just say like anecdotally from my messing around with the algorithms and running tests, like these were outliers. So the runtime is I believe is accurately reflected by the test, but I'm very happy to publish the complete.
And I could try to do the same benchmarks again on the exact same computer that the original ones were made on, and yeah, if I get the same kind of numbers, I'm all for it.
And if I can chime in for a second here, from a very high level, the reason these were priced so high in the first place was to prevent DOS attacks from a relatively new on-chain primitive, right? We have no evidence that DOS attacks are forthcoming. The actual compute time cost of these is much lower than the gas cost would imply. What we do have a lot of evidence is that developers are excited about these. A lot of projects at every ETH Global Hackathon working on snarks and on-chain verification of snarks and signatures, right? So we've gotten rid of the reasons to price these high, and we have a lot of reasons to make these more accessible to everyone.
I have a quick question. Is this something that the precompile for elliptic curve linear combinations EIP that would make that generic enough we wouldn't need this, or is that not the case? Because I know there's other EIPs where that is the case.
I believe this is the alt-BN specific pairing operations, not the general elliptic curve operations.
Okay, so that wouldn't be included in there. Got it.
And to add to that, Hudson, I mean, I have no idea if that's the case, but I totally agree that if we can make these cheaper, we definitely should, because we went through all the trouble of putting them in there, and if no one's using them, then it's wasted effort, and it's extremely cheap. I mean, extremely easy for us to just lower the price, but we just need to make sure that we're not opening ourselves up to DOS attacks.
Okay, so it sounds like this is approved pending a benchmark that will be reviewed by the next meeting.
A correction regarding the generic one. The generic one does support BN128. The proposal for a generic precompile. But I don't think this should make any difference to the question whether the specific BN128 precompile should be adjusted or not.
Well, yeah, but currently
Okay.
the one that we have is not usable because it's too expensive, and if there's no point to keep it that expensive, then I mean, even if we add the generic one, there's no reason to keep this one unusable.
Yeah.
You're just saying what Alex just said, basically, right?
Yeah.
Okay. So yeah, approved pending a full or a more full benchmark. Sounds good. We're not gonna get through all these today. I'm calling it now, but we'll see what we can do. Um, Precompiled call opcode to remove call cost for precompiled contracts. That's EIP 1109, and that one it's loading is Jordy's EIP. So
Can I have a quick comment?
yeah, sure.
I've been commenting on that one, and initially it was a different. The proposal was very different. It was about changing the existing calls to behave differently if they are targeting a precompile, but that was changed into proposing a specific opcode. But I couldn't reach Jordy for a couple of months. He wasn't responding on the forum, so I made another EIP, the last one on the list, 2046, which practically is doing the original proposal. It only changes static call to behave differently. So I think these two should be discussed at the same time, but I'm not sure if we can discuss them properly today.
Okay, so you don't want to really discuss 2046 today?
I mean, 2046 and 1109, they are practically solving the same problem, just different proposals for the same. I think they should be discussed together, but I'm not sure if we can discuss them together today.
Just to add my 2 cents, I kind of like the original approach too. That if we can make the original calls a bit smarter, that seems better than introducing yet another opcode which does the exact same thing just at different pricing. Hello?
Oh, I've been talking and I'm on mute. I said, okay, we will table that one, and that'll stay in the proposed category, both of those. And then hopefully Jordy can chime in, and if not, we'll just use Alex's if everyone agrees on that one.
Could you list them somehow in the listing so that it's clear that it's either or?
Yeah. So after this is done, I think it was James Hancock who was keeping up with which ones are accepted, rejected, and proposed. Is that right, James?
Actually noting it in the chart while we're talking.
Oh, wonderful. So there's a Google Doc. And so now there's 3 places for these to be. There's the wiki, there's the meta EIP, and there's a Google Doc. The Google Doc is going to be most updated. The meta EIP is going to be probably least updated along with the wiki at this point. And that's more because James is doing the work, so we'll just use his source of truth. Next up, oh, did anyone else have comments?
I'm just wondering why cannot we keep the meta EIP updated?
Oh, we can. I just didn't know anyone was doing it.
I mean, anybody can submit a PR based on the discussions.
Okay. James, are you cool doing that as well?
No, but I can work on the wiki too. I'm working on the testing, on coordinating testing, so I kind of have to do this already. So I'm doing it.
Okay, thanks so much. So the next one would be net gas metering for S-Store without dirty maps.
With this one, so essentially, this was the same pull request, EIP that we nuked out from Constantinople. And what's the difference between this one and the one that turned out to be broken?
I can comment on that because I've seen the pull request when it was added back in. There's no difference. It's the same proposal, but the author wants to propose it together with account versioning and only enable the change on accounts which follow the newer version.
So from a process optics, I would prefer to see this one under a new EIP number since we already tried to deploy it and had to pull it out.
Actually, I think it's good. I mean, it is the exact same EIP. So why should it be changed number?
The exact same implementation that we pulled out?
It's not.
Is it a different one? It looks like the
It's a
exact
tweak.
same one.
It's a tweak. It's a small change, but I think a new EIP would make it clear that we're doing the version of it with the change.
Oh,
not the one
sorry.
that caused the
The other
problem.
one was 1087. And this one is 1283. Right?
Now this is the old one. There's no change made to it yet, but I would agree what was said that probably a new version of it should be made, which has this change saying it's only enabled on a specific version, and it requires the account versioning.
Just into that, I would really like to see a section on it discussing the reason why it failed previously and why that's good or bad currently.
Okay. Phil, could you let Wade know of our request? It's also, if you didn't catch all that, it's going to be in the notes and probably the summary after this call. Hey, Phil, you're muted if you're talking. Okay, I'll reach out to Phil afterwards and make sure that, or Way, I can even reach out to just Way directly on Gitter.
So to clarify, this is as was implemented for Constantinople, but requiring the versioning bit turned on?
I think so, but it's not clear because the author hasn't fully explained it. That's why I agree there should be a new EIP referencing 1283 and explaining the differences. So I don't think we can actually make a decision because we don't know what the complete proposal is.
Yeah, this is definitely going to stay in proposed for now. And I'll talk to Way afterwards about creating a new EIP. So that's going to be an action item for me.
By the way, just a tiny nitpick. If we are going to propose a new EIP that is essentially a tweak of an old one, perhaps we should retain the original's authorship. So since Nick Johnson kind of developed the whole thing, it would be nice to keep him in the list too.
I had talked to Way about that before and to Nick, and I think it was decided that Way was going to maintain authorship of that particular EIP because of the changes that it made from Nick's EIP, and Nick was okay with that.
Okay.
What's the next one? Man, this list is long. Add chain ID opcode, that's 1344. I felt like this was non-controversial, if I remember.
Yeah, I think only Christian had a counter argument that it's one extra opcode, one extra byte loss, but otherwise.
I know also that someone has filed competing EIP. I guess he didn't make a pull request to this meta EIP. But the other EIP proposes that you could, I don't know, help me out, test a certain block number if a chain ID was active at that point or something.
Yeah, those are included here. It's 1965 and 1959.
Okay, so those three are also in XOR. Yeah. So I guess those should be discussed at the same time.
Okay. What were the two? 1959 and
1965.
65. Okay, I thought it was 85 for a second. Okay, we'll start with 1965. Method to check if chain ID is valid at a specific block number. That was Ronin, and they aren't here. And 1959 is also Ronin. So do those go together?
It's the same EIP. One is an opcode and one is a precompile. I advocated for the precompile to preserve opcode space. So I think the choice is really between 1965 and 1344.
Okay. And let me just look at how complete this EIP is. Okay, the spec and everything else is fine. It doesn't have test cases, but I don't think test cases are needed for something like this, right? Or not for a precompile that they would write down in the EIP. Am I wrong?
I would like test cases, but I don't think it should be a blocker today.
Okay. Yeah, and actually test cases is TBD. Yeah, we can maybe go ahead and just accept or deny this one. So, it's between.
So the first one to get the current chain ID is a trivial implementation. The other ones, I think maybe are not. Then I mean that would basically require the client to maintain a mapping of all historic chain IDs, which on the mainnet would not be a problem. And well, did we ever actually change chain ID in the history of any network?
No,
I
this would
think
be
we
support
just
stuff like
enabled it.
Etsy. Sorry, go ahead.
Sorry, I was just saying that I think we just enabled it during the. Oh, I'm not even sure. I think it was Homestead or after Homestead.
Yeah, Dana, what were you saying? You said it is?
It's to support like chains like Ethereum Classic and other ones that want to do a contentious fork away from any of the other Ethereum chains, like a contentious Ropsten fork or something.
Yeah, so it's basically laying the ground for if something else, if someone wants to break out from Ethereum mainnet and have switched the chain ID, right? That's when you would want the history. Otherwise, it would be sufficient just to have the current chain ID.
There's also some models of non-mainnet chains where when they fork, they change their ID to make it clear that they've changed the rules of the chain. So it's not always a contentious fork, and it's not always forking off of mainnet. But I think that would be something that could be introduced on their own clients. I don't know if it's a requirement for a mainnet client to support it. Would be my opinion of it. So I think they both could go in, but I also think they can go in independently.
There was some kind of EIP for precompiles, like custom precompiles that maybe this kind of fits into neatly. That non-mainnet networks can add a custom precompile that does this.
1352 is the next one on the list.
Okay. Let me try to get Ronin and see if they can advocate for this at any point and say which one they prefer since they submitted two. And we'll just table this, and for now I'd say, or does anyone else have an opinion?
So between the two of them, I kind of concur with Martin that the opcode one seemed like a really trivial thing. I mean, get the current chain ID, here's the current chain ID, and you can do whatever you want with it. And I mean, if a past chain ID is important for a contract, then they can even store it or something. Whereas the alternative, where you can look up the chain ID at an arbitrary past point in time, and one of the weird quirks is that why does the EIP specify that you should test whether the chain ID is something versus just return it? It would seem a lot more meaningful for me to just return it, and then the contract can do whatever you want. But
So
yeah,
I actually asked them about that on the PR, and as far as I understood it, it's because it's considered that how was it? at an earlier point in history, if you're now on chain ID 5, it was considered that even at block 0, that was a valid chain ID somehow. It was something to that effect, that the subset only decreases. Maybe I'm just confusing things here. But he did answer that question on the PR for that EIP.
So I motion we accept 1344 and we table 1965 for further discussion.
Okay,
I agree.
that sounds good to me.
No, wait. So
All right.
you said we accept 1344.
Yeah,
No,
1344.
but then we reject the second one. I mean,
I think 1965 can go in with both of them. I think 1959 is the only one we need to reject. That's two versions of the historical one. Historical and current, I believe, can both go in.
I don't really agree with having two mechanisms to do the same thing. I mean, just pick one.
Okay. So there's no consensus, so we need to table both of them.
Is it possible to take this offline and review all three?
Yeah. Yeah, that's why I was saying I need to reach out to Ronan. So I'll put that down. Reach out to Ronan
I guess
about
Brian on that call as well, if we're going to discuss them all three.
Oh yeah, and Brian. I know Brian. I actually don't know if I've ever met Ronan. No, I've met Ronan. Okay. 1352. Specify restricted address range for precompiles and system contracts. Was that Alex? I'm guessing. Yeah. So, Alex, if you want to give just a quick, I thought this was just setting out address range spaces for precompiles, so it doesn't seem controversial.
I mean, does this even require hard fork?
There were some suggestions that it may not require hard fork. It should be just accepted or made final. And maybe some tests would need to be added into the test suite.
So that was my question. How does this affect EVM runtime at all?
Well, it should not.
Oh, so it shouldn't even be in this list. Okay. Cool.
But was there any intention to like refuse contract creation to these addresses?
Actually, that's an interesting question, because on private networks, it's totally possible in the Genesis to set a contract on these addresses. So at that point, this EIP needs to let us know, the clients know, how should we handle that.
Another problematic thing is if we specify that this is in a restricted address range, is that previously when we had the cleanups, the Tangerine Whistle or whatever hard fork, where we cleaned up the empty accounts, we actually accidentally deleted the RIPE-MD, and then every client now has this weird special clause in the code base that RIPE-MD is a special snowflake. And the reason why the rest of them weren't special snowflakes is because somebody actually sent one way to every one of them so that they become non-empty. But I think we only sent one way to the first 256. And then, okay, what happens with the higher ones? So it's a bit of a weird, I mean, the CIP doesn't really provide any value, but it does make reasoning about things a bit more complicated, because all of a sudden you can misinterpret things more easily.
Well, it is a prerequisite to some other EIPs, which don't want to list every single precompile when making cost to precompiles cheaper, as an example.
Right. So one thing that I think should be answered by this EIP is, if there is an existing network which has EVM code on one of these addresses, what will happen with those? I mean, those future EIPs, which lower the cost of precompile calls. How should they handle that? That's one of the questions I have.
Well, honestly, I would say that precompiles should be at least in Get, we have a list of precompiles and hard-coded addresses. And in my opinion, if you want to make precompiles free, so to say, I mean calling them, then essentially they shouldn't depend on the address. Rather, they should depend on how the chain is configured. If the chain defines that we have 8 precompiles, then it doesn't matter what you have on what address, those 8 get the free waiver and the rest of them have to pay. In my opinion, that would be the logical behavior.
Yeah, I agree, because those contracts, they exist as methods already in the EVM, whereas the other stuff needs to be looked up on this.
Okay, so it sounds like there needs to be more work on this. Alex, can we like bring this together and Fem? Oh, you're muted if you're talking.
Sorry, I didn't catch it.
Oh yeah, I was just saying, is it okay for this to be tabled?
Yeah, it definitely should be further discussed. There's the discussion URL, which probably is the best place to do it.
Okay. Oh yeah, there is one. I thought there wasn't for a second. There is an Ethereum Magicians thread. Okay, great. So there's a few people who are on the call today who came on the call specifically to advocate for their EIP. So instead of going in order anymore for the last 15 minutes, let's run through those EIPs. I know that a big one was the fee market change for the ETH 1.0 chain. It's 1559. Rick, is that the one you're championing?
Yeah, that's me. I don't see how we could possibly make it in Istanbul. I mean, well, let me rephrase. It's actually possible that we make it in Istanbul, but it seems unlikely. So I don't know from a process perspective how to move forward. I mean, we're making progress, but it's a pretty complicated change.
Sure. So it would just be delayed till the next hard fork.
Yeah,
that's pretty much the process, and you would continue to work on it, and we can discuss it in further core dev meetings as it comes up or needs to be discussed.
Okay, so that one, I think we should assume that it's possible that it'll make it in because it's so far ahead, which is good, but it's difficult to say. I mean, it seems unlikely right now.
Okay.
One thing that I've never seen this EIP until now, so apologies if I'm saying something stupid, but skimming it, could you also try to briefly talk how, I mean, not here, rather on the EIP, how this whole thing affects networking, for example, and transaction propagation? Because the transaction pool logic is really heavily tied into how the whole how miners accept different transactions, and if you start changing that logic, then maybe the networking layer needs some patches too.
Yeah, I'd be happy to make those changes. Can you just make an issue so that I'll address it in the EIP?
Yep.
Okay, thank you all. Next up, let's go to EIP 2045, which I'm actually not even sure if this is a proposed one necessarily, but Casey was in here to talk about that today. So Casey, if you want to just for a couple minutes discuss what this is and if people should look at it or what's next.
Yeah, sure. So it is proposed. There's a PR pending to add it to the meta EIP for Istanbul, but in brief, gas costs are balancing 3 separate things: disk I/O, network I/O, and computation. Currently, disk I/O is overutilized and is the bottleneck. Network and computation are underutilized. So because they're overpriced is the main reason they're underutilized. So there's the EIP to reduce the price of call data, which will help better utilize network IO. There's an EIP to increase the price of S load, which will help rebalance disk IO. There's EIP to increase the price of S store and create2 and so forth. And that makes it possible to boost the block gas limit while maintaining the same rate of state growth. If we boost the block gas limit while simultaneously increasing the price of state growth, that's effectively the same as keeping the block gas limit the same, but reducing the price of all other operations, all the non-state expanding operations. So that's, again, computation and network-related operations, which is reading the price of transaction data and call data, or call data. How much can we reduce the price of transaction data depends on when bandwidth becomes a bottleneck. How much we reduce the price of computation depends on when computational opcodes become the bottleneck. So currently, computational opcodes are mostly not the bottleneck, even in unoptimized clients. So that's what Martin Swendy's recent benchmark showed, that S load is the biggest bottleneck. And so the EIP to increase the price of S load proposes taking it from a gas cost of 200 to a gas cost of 800. Even after that 4x increase in the cost of S load, it would still be the bottleneck according to those benchmarks. So then note that these benchmarks were done on Geth. So just using the speed of computation on Geth, the benchmarks show that that either the cost of disk IO needs to be raised substantially, or the cost of computation should be reduced, or a combination of both, because the costs are all relative. So reducing one is the same as raising the other. It's equivalent. So what's kind of crazy is that if you benchmark Geth against an EVM implementation that's optimized for speed, computational speed, like EVM1, which is what we did, and the graphs of those benchmarks, they're linked in the agenda and they're in the EIP, and they show that we can get like a 10x speed up from optimizing the EVM. So the proof of concept that fast EVM implementation that does this it's called EVM1, and Pavel he wrote it for fun during Christmas break. But so that's two significant speedups, which are basically low-hanging fruit right now. So the first is just rebalancing the costs to the current Geth and parity speeds. And then the second speed up is optimizing Geth and parity to get the same speed up as EVM1, or you could just use EVM1. But a fun thing to try is then to take EVM1 and benchmark some of the most optimized EVM contracts. And so we did this with a contract that Zach Williamson wrote. He was speaking on the call earlier. The contract called Wirestrudel. It implements the same. It implements EC-mul. So this is the elliptic curve multiplication, the precompile that was added in Byzantium. So it implements the same thing, and it beats the precompile in gas costs. In computation time, EVM1, it executes this EC-mul in 500 microseconds, and that's compared to native Rust, which parity uses for that precompile, executes in 300 microseconds, and Geth is more optimized with some native Go and assembly, and it runs in 100 microseconds. But the fact that the EVM bytecode that does the same thing as the native precompile in 500 microseconds compared to 300 or 100, I think those results are pretty shocking. So that an optimized interpreter executing optimized bytecode can achieve speed not a lot slower. I mean, I would almost say it's near native. And even that result of 500 microseconds isn't the best we can do. There's more optimizations remaining there. Like a well-known one for elliptic curve is Montgomery multiplication. That wasn't done on Wirestrudel because Wirestrudel was optimized for gas costs and not speed. And the price of mole versus mod mole is not really accurate to the runtime. So the more optimized one would be even faster if we benchmarked it, although it would cost more gas at the current gas right now. I mean,
I'm gonna time box this to another minute.
that's it. So I wanted to ask Zach if that's right about that those current benchmarks for Wirestrudel. It could be optimized to be even faster. Isn't that right?
Yeah, it could. As you said, Montgomery multiplication probably would speed it up by, I don't know, maybe a factor of 2. But yeah, I optimize for gas, not for runtime.
Yeah, so I mean that's it. The conclusion is there's room for substantially reducing the gas cost of computation, and we need fractional or some way to price opcodes below the minimum unit of 1.
Okay, thank you. And is there a discussion link for this? Which EIP specifically?
Yeah, it's on. There's a Magician's post for it.
Okay, great. And then lastly, I think this is going to be one of the last ones. James Prestwich is advocating for a couple of EIPs. If you can explain the EIP, what their name is, and spend a few minutes explaining what it is, and if you want people to comment on a certain thing.
Okay. So the first one I wanted to talk about is 2024. This is Blake 2 precompile. So far, Ethereum only supports SHA-2, a very normal standard hash function, and KEKEK256, which is completely weird and an accident of history. For people like me and the Zcash Foundation and the IPFS team who work with different hash functions that are common and well-known these days, like Blake 2, it would be nice to have access to those on-chain. Some specific things this gives us is equihash evaluation efficiently. Right now, it takes 16 million gas to evaluate one equihash at low security parameter. For other chains that are going to use it at higher security parameters, it would take 32 or 64 million gas to do that. So I have a use case in mind for this today that I could implement, with just the Blake 2 precompile.
A comment on that. The benchmarks that I just referred to, there's even a more optimized Blake 2B bytecode that Zach did, which reduces the gas cost by a lot. And then when you benchmark it in EVM1 and a fast EVM implementation, it would be plenty cheap enough without a precompile.
So the thing about equihash is that you have to do 32 invocations. So even if you reduce it by an order of magnitude, you're still looking at 1.6 million gas per invocation. In order to verify a set of Zcash headers, for example, you'd need to do somewhere in the neighborhood of 30 to 40 invocations, depending on how much security you want, right?
The reduction is more than an order of magnitude, but
okay, great. So how much are we talking on-chain optimized gas costs today?
Yeah,
I can feel that. So actually, I'm happy to share the source code with you because, basically, I think it's about 30x less than the old like 2p hash function.
Okay.
Yeah.
So about 30x less. So we're looking at.
Well, then you get a 10x on top of that because it's the speed up from an optimized EVM.
Does
Right.
anybody use an optimized EVM with appropriate gas costs in production?
Well, that's what the proposal is, to, instead of adding more precompiles, to reprice EVM opcode costs so that we don't continually need more precompiles.
And did we land on accepted for that one?
No, not yet, but I'm just commenting that it helps. It would help here.
I'm sure it would help, but the question here is whether this is a useful thing within the next about 11 or with an 11-month lead time. assuming that the next hard fork has about the same lead time, we're looking at 12 months after that, so a 23 to 24 month lead time for something like this. I think, even assuming that this optimization comes out in 2 years, it puts us in a really uncertain place with the launch of ETH2, and it's a full year slower. So for those of us who are looking to implement things, it's really not a meet in the middle kind of option. It's a hold off and we'll see what the landscape looks like in a year.
And if we can connect you with Zach and Casey to further this discussion, I think that would help because of our time restraints on the call.
Yeah.
And then if you want to come next week, James, or 2 weeks from now and continue the discussion, just because I didn't give you a ton of time, that's perfectly great as well.
Yeah, no problem. I will probably be on a plane at the time next week.
Oh, it's 2 weeks from now, sorry.
Okay, 2 weeks from now. So are we holding open these discussions on EIPs for 2 more weeks?
Yes, as if they are completed and ready to, not implemented, but if they are completed by as far as being merged as a draft and having the motivation and specification sections and things like that, they can be considered for Istanbul.
Okay.
As long as you spur a discussion on Fellowship of Ethereum Magicians and the All Core Devs Gitter channel and get a little bit of consensus on it.
Right.
I just have a question, because you were derailed a bit. You were talking about use case. So is the use case cross-chain swaps between? Could you tell us about the practical?
That is one possibility. Other possibilities include like tokenized assets. You can do, well, like I mentioned with IPFS, you can do a lot more verification of off-chain data using Blake 2. You can also use it for Decred, cross-chain interoperability. Blake 2 is a relatively uncommon but normal hash function out in the wild.
Yeah.
And actually, I think we have Brad here to talk about that today after you're done with your comment, Martin.
Yeah, I was going to say, so we have and have had for a long time BTC relay. I mean, we have possibility to do cross-chain swaps with Bitcoin, the biggest, but it's not used.
If you'd like to read my extensive articles on why BTC relay isn't used, I'd be happy to link them.
Yeah, I'd actually be interested to read that.
So I'm happy to point you to them if you shoot me a message after this. One of the main really cool things that differentiates this from BTC Relay is that the Zcash team is considering Fly Client Merkle Mountain Range commitments for their next hard fork, which would be about 6 months from now. So getting a Blake 2 precompile into Ethereum on a slightly longer time frame would allow you to do not just a Zcash relay, which would be prohibitively expensive, but the ideal minimal Fly Client relay, which is orders of magnitude more efficient than relaying every header. So it's kind of like a unique opportunity here, because the Zcash team is looking at hard forking in features specifically for this as well.
Cool. Yeah, that's
okay.
Interesting to hear, because I mean, BTC relay never took off, so I wouldn't like to implement Blake 2 and have the same failure with Zcash.
Yeah.
So, sorry we're going over time, everyone, but I definitely wanted to introduce Brad Miller. If you want to do a quick intro, Brad, and then just say why you're here.
Yeah, thanks, Hudson. So I'm Brad Miller. I'm the Developer Relations Manager at Electric Coin Company. And honestly, James did a phenomenal job framing, a lot of the reasons why we want this. I was really here just to show support and to make sure that we at least have some more time to try and make sure this can make it into Istanbul. We're very interested in seeing it push through, and I'm personally shepherding this effort on the Electric Coin Company side, and I can coordinate also with the Zcash Foundation. So, I think all of the technical reasons that James laid out at least present a strong case for it, and now it's just a matter of making sure we find the appropriate people to champion this forward. So thank you.
One thing that I
Okay.
would like to add that so here we kind of have two approaches. One of them is cases one EVM, or what's it called. That one probably. I mean, I'm not sure whether that would fly ever, because that would require all clients to use a single EVM implementation. So that's probably a very political thing. But that said, the precompile approach to me seems like a trivial EIP or trivial feature to add, because essentially, for example, Blake2 is a popular hash function. It's implemented probably in every single language out there. So probably integrating that would be half an hour's worth of work. So from this perspective, if there is a legitimate use case, I think adding a precompile for a couple of high-profile functions seems a no-brainer.
There's also been quite a bit of work already done on this, which is, another, I think, positive. Somebody at Electric Coin Company previously did quite a bit of work on this. Jay Grabber, she was, I guess, one of the two authors on the original EIP, as well as the reference implementation, I believe. So.
Yeah, I believe we discussed it like 2 years ago and we're positive against it. It just never got in.
There are also use cases for Blake2s. Would the precompile include Blake2s functionality, or just Blake2b?
This one was just for Blake2b, I believe.
Okay.
But
yeah,
so I guess we can make a list of, for example, make a list of hashes that we would like supported, and I mean, adding one hash or adding 5 of them is probably the same effort. Maybe testing them is a bit more effort, but it's not really an effort to support new hash functions. So I don't really see the reason why we wouldn't do it. I mean, the precompile address space is kind of infinite. Adding code is just pulling in an external library, because obviously nobody's going to implement it from scratch. It's just figuring out gas prices.
Yeah, I didn't mean to suggest that we should do EIP 2045 and reduce all the computational gas costs instead of adding Blake2b, but just to point out that the need to add Blake2b now, there is another option which would potentially supersede both the precompile for Blake2b and many other use cases.
Okay. All right, thanks everyone. There is a Fellowship of Ethereum Magicians forum for Blake2b that people can participate in, and I think Brad and James are monitoring that one as far as I know, and that's in the EIP. Thanks everyone for coming today, and we'll talk more on the Allcore Devs Gitter channel to try to kind of wrangle in some of these EIPs that are still stuck in proposed, and as quickly as possible decide on which ones are being implemented for Istanbul. Thanks everybody, and we'll see you in 2 weeks. Goodbye.
Thank you.
Thanks. Bye.
Bye-bye.
Bye all. Thank you.
Bye.
Bye-bye.